This is 2.4a, College Algebra, Analyzing Graphs of Quadratic Functions, page 216. So what we're going to do is continue looking at parabolas, because whenever we're graphing a quadratic, that's what we end up with, is a parabola. And the parabola is going to begin looking like this, and then just like we did in the last chapter, we would do things to it. So we would have something like, we'd put a number in front of the x squared, like that. Or we might put a number and then do x minus h and then square it, and then add a k to it. So what we end up doing is stretching it, shrinking it, horizontal translation, vertical translation, and it moves the graph all over the place. If you look at the top of page 217, depending on what you do to our initial function f of x equals x squared. One of the things that I need to remind you of is the hk is called the vertex. The h is the x, and the k is the y. And the vertex is either the maximum or the minimum value. Each graph has a line x equals h that is called the axis of symmetry. So when we have our graph, and we have let's get the graph up here. We have a graph here, and if x equals h, that means we go over, say this far. This vertical line here is my axis of symmetry, where the distance of x is also the distance of h, which tells me where the vertex is going to be along this line here. That's what the h means, is that's the x value of the vertex. Okay, so that's up through page 217. If you look on page 218, it gives us a function, it gives us a vertex, axis of symmetry, maximum, minimum points based on a particular equation. So let's put that up here. Okay, so given this top equation we have here, let's look for the vertex, axis of symmetry, and the max min point. Now, one of the things that's important is it has to be in this format in order to do that. So some of these later equations we're going to be given, we're going to want to get in this format, so it's real easy then to find this information so that we can go ahead and graph it. So the vertex here is my hk. So let me put on that general form of the equation again so that you have that. So we have f of x equals a x minus h, quantity squared, plus k. Okay, so that's the format that we want this to be in, and it's already in that format. So the vertex is my h and my k. My h and my k. Okay, so my h is 1/4, and my k is -2. See how it's got the minus sign there? So then we just look at the h, which is 1/4. We ignore the minus sign. And this says plus. So this is actually plus a -2. So therefore my k is a -2. So I'm going to have, for my vertex, 1/4 and -2. So 1/4 over on the x-axis, and then down 2. That'll give me my vertex. Alright, my axis of symmetry is always going to be my h value, and in this case my h value is again 1/4. And that will always be the case. These two will be the same. And then my maximum point, this number right here is positive. So if you remember, when the a is positive, it opens up like that. So that means there is no maximum point, but there is a minimum point. And that minimum point is the lowest point on the y-axis that is on the vertex. So the vertex is 1/4 -2. So therefore the minimum point is going to be the lowest point, which will always be the vertex, or the maximum point, which again will always be the vertex. So the minimum point is my y value. So that's going to be -2. Alright, so let's erase that one and try another one so you can see it again. Okay, so we're going to look at this one here again. So we know our vertex is our HK, and our H is right here. And in this case, it's supposed to be x minus h, and here we have an x plus 5. So that means this must be x minus a -5. So our vertex is -5, and then our k is going to be 7. Okay, because these both show a plus here and a plus here. Now remember, this is x minus h, but it says x plus h. So it must be x minus -5. And then we just take the -5 of it, because it has to be in this format. Over here, it has to have this minus sign. So what does this number have to be in order for that minus to change to a plus? A -5. So they're both negative. Axis of symmetry then is my x value of my vertex, and a max-min point, it's negative. My a is negative, so therefore it's going to look like that, which means I have a maximum point, and in this case it is my 7, and I don't have a minimum. So that's it. That's as far as being able to graph quadratic functions of that type. So let's look at some quadratic functions of another type. Okay, so here's our other type. So we're given an equation this way, but before we can graph it, we have to turn it into this. Remember, I warned you about this earlier? So what we're going to have to do is we're going to do some completing of the square of this to get it to turn into this so that we can actually graph. So let's look at one. Let's look at f of x equals x squared plus 10x plus 23. Okay. So this can be a little tricky, so just really watch what's happening here. What we're trying to do is find this right here, which is the x minus h times x minus h. So that's what we're trying to do, is break that down. So we're trying to, well, let's just do it. Let's just complete the square. What we're going to do is we're going to put this here, and we're going to put the plus 23 over here. So we're going to take our term with the x variable, we're going to take half of it, and then we're going to square it. And we're going to do this. Okay, this is still f of x equals. Okay, so see what we did? We took the 10, took half of it, and squared it, because when we do that, when we get that there, it will eventually reduce to x plus 5, the quantity squared. That will take care of that right there. Okay, so that's why we do that, is because then it begins to look like this here. So we had to take half of that and square it, so then it factors down to x plus 5, the quantity squared. So that's why we added 25, is so we could get that. But we added 25. We just took one side of the equal sign, this side over here, and just added 25. Well, you can't just do that. So what we're doing is we're going to take that, put parentheses around it. And that means we can get that there. Okay, so because we did that, added 25, then on the outside of these parentheses we're going to subtract that same 25. So actually we're adding 0, but we're grouping here so that we can do what we needed to do. So this here then becomes minus 2. So if you were to take x plus 5 and square it and subtract 2 from it, you would get this equation back right here. We just changed the way it looked. We have x squared, we have 10x, and we have 23, and we added 25, subtracted 25, which is 0. So this is kind of the simplified, and this is unsimplified, where we combined things and ended up getting this big long thing, but when we bring it back we get this, or we get this. Okay, so that was the reason we did that. So because this is a plus sign, and up here we need a minus sign, let's go ahead and rewrite this as f of x equals x minus negative 5 squared minus 2. Okay, so once we do that, it makes it really easy to find the vertex, because the vertex is going to be negative 5, and it's going to be negative 2, because this is going to be really a plus negative 2. We need to make sure we do that as well, because again I didn't look at that. This is the plus k, so it has to be plus here, so it's plus negative 2. So that's my vertex. My axis of symmetry will again be my h value. It's going to be that, so my axis of symmetry is negative 5. And my minimum value of the function, because the a is positive, it's going to open up like that, so I have a minimum value rather than a maximum value, and my minimum value will always be the y value, or the maximum value will always be the y value of the vertex. So there we go. That's how you change from this form to this form, and then do a quick graph.